How you doing, everybody? Randy Richards in the shop. Back on the Hemingway kit, spherical turning tool, and we're making the brass locking. What do they call it here? Locking. They call it locking screw. Not sure why it's a screw, but anyway. Oh, the screw is the 9. This is the locking nut, number 10 here. There's a little picture of it, and this is the detail of it right here. And we'll hold that up right there. So we're looking at part 10 and these here renditions there. And where it goes though is it fits. Actually, it will fit in this hole here inside the head. And here's another you'll see the brass is right here. Piece here. This is a threaded piece that goes in through there in it. That's with the dial. So over to the lathe and we'll get this quick part done. We're going to come down 3/8 of an inch. That's it. Now we're going to test it in the head here to see how that fits. It's not too tight. It's supposed to be a sliding fit. Right now that's a press fit. Yeah, I might have took a little too much. It's a little more than I kind of like. Kind of a little bit of play there. I've got more brass. Let's try it on there. Oh yeah, I measured the hole with a 249 pin, and it slid in there very nicely. But this is 249. I measured this at 249.6, so that's a perfect fit. We're going to part this off a ½ inch down from there. So right about that blue mark right there, it's good enough. This is just the rough part of doing this. For this part, this is kind of like stage 1 of this part. So for stage 1, we're done with that. Now get it back in the mill. Now I did not Loctite this in, but this fit very snug when I went to push it all the way in, so I tapped it in and it's very tight. Because I'm going to have to take it back out. Now I'm going to take that out and then go in and knock that bridge out. Well, we're up to the point here we're going to thread the locking screw. No, what do they call it? I'm sorry, they call it the nut. Yeah, they just call it the nut. And 1/4 inch 40 thread in that little hole. And that's the shape. So what I've decided I'm going to do is, here's a gauge pin. It's a 218 gauge pin, fits in there just perfect. We'll use this to line up in the forejaw on the Logan lathe. We'll be using the Logan lathe. I don't have a center hole in this pin, but we'll be using this, and we can dial indicate on the pin. That's the plan, at least. I might even use some medium Loctite, and just Loctite it in the hole, I'm thinking. That way it's solid in there, and then I can get that out. But we'll see. We're gonna just hold it in the forejaw, dial indicate that pin, and we should be pretty aligned, pretty good. And we're gonna single point the thread. Then what we're gonna do is, after we're done with it, we'll put it in the mill, and I'm gonna use this radius cutter. This is a woodworking radius cutter, carbide, and we're going to chamfer each side of the top of this so it fits. So when it's inside the head here, this will fit in the bore of the slide. So that fits right, will fit right in that bore. So we'll knock off that. All right, we got this just kind of sitting in here in the Logan lathe, and I put just a little bit of blue Loctite on the end of it and locked it in the piece. And I got my indicator, and just by eyeing it I can see some misalignment, and we're just going to work on it. I'm going to work on this end kind of first and see how close we can get it. This one jaw is going to be a little close. We're going to try it with this method. If this doesn't work, if I can't get it lined satisfactorily with this method, I'll remove the pin and I'll put my ID attachment on and indicate the inside of the hole. Now I have a 1/2 thousandths indicator on also. Quite a bit out. I just eyeballed it on the jaws as far as centering goes, and it's too high right now. I got a piece of drill rod in here. Turn it down to 250. I'm just going to make a tap for the 40 threads per inch. All right, it looks good. or 268.5. Our max is going to be 265.2. A little bit more. $265.4. So we're right there at our max. I think I'm just gonna leave it right there, and just kind of buff those threads a little bit. I think it'll be just fine. All right, we're milling the tap here. We're going to try to at least. That's 4 flutes. I'm only going to do brass. Only has to work once. But I think my depth of my flutes are good. I got 4 flutes. I'm going to make the taper a little bit longer, just a tiny bit, so it starts a little easier. So we'll put it back in the lathe and turn a little more taper on it. I think that looks pretty good. I put a little longer taper on there at about 7 degrees. I think it'll be good enough. Now I'm going to turn the shank down to 1/4 inch, and then we'll put a little 4 flats on it so we can drive it like a regular tap. Turn that stuff fast, high surface feed, and you get great finishes on it. I left that about, that's a 260. I'm just going to leave it a tiny bit big. We're just using this part. It's a very special tap, right? And we'll cut it off, and we'll put a square on the end. There's our finished tap. Squared off on the ends, and I center drilled it. So it came out pretty good. Pretty happy with all this. I haven't tried it yet. Now the question is, do I harden it or just give it a little surface hardening for the cutting edges? Probably that's what I'll do. Probably just heat it up and surface quench it and leave it hard. Gauge pin 218 that fits right in the hole. I just used this to align it and then locked it in with the indexer right in the collet. Got the tap in here. Now I did pull the old torch out and heat treated that. Came out pretty nice looking. We'll just see how it works. Functionality. It's all about functionality, right? A little oil on there. It's not going in. Okay, why is it not going in? Maybe not enough taper. Back to the drawing board maybe. I went and did some calculations and their hole size is not correct. I'm now drilling it to it should be 0.225. All I have is a 228, so we're going to go with that. I should have checked that before. Failed to do so. Now we're going to try it tapping it again. Now that's going in. That feels way better. We were cutting threads before, but boy, that wasn't right. Now I hope I have enough threads on my tap. That's about it. It worked just fine, but when I cut more taper off, well, I lost some of my threads. I was hoping I'd have enough, but not quite to get through. It's hard to see in there. Anyway, they look really, I'll clean them up. It looks pretty darn good. A little hard to see in there, but they came out really nice, actually. Just not all the way through. We're just shy a little bit. I'm going to actually call the tap really quite a good success. I just didn't need to taper. It was more the starting with a right size hole. So like I said, I should have done the calculations ahead of time. All right, I have the thread all the way through now. I went back and I was able to turn down a short portion of the tap to below the minor diameter, about 218 I took it to, so I could run the tap all the way through. And now we have threads all the way through, and they came out really quite nice. Now we'll make the screw for it, and we need to round. I rotated the 5C collet indexer vertical. I have the part in the collet, and I have my quarter round in here. This is a 1/2 inch radius quarter round, and we're going to nip off each side. That's probably going to be pretty close to enough. I might have to, address it with a file a little bit, but that's just a custom fitting. That worked really well. There we go. I slipped it in there. is just a little bit on the high side as far as the height goes. Kind of difficult to see, but anyway, we're going to just dress a little bit with the file. Little file work, and we have it sliding just perfect over the nut. There we go. You see in there. So that's what we want. Now on to the next part. I think it's to make the shaft. No, the screw is the very last thing. So it's tool holders and the handle still. Thanks, you guys. Thanks for watching. It's coming out good. Coming out good.